Good evening, guys. Today we will take a look of a high voltage power supply, an electrophoresis power supply, I think it's called like that. It's a PHARMACIA BIOTECH EPS 3500XL, which means that it can output 3.5 kilovolts or 3500 volts at a total of 100 watts and a total of 150 milliamps. That when I say a total, that means that it can only output up to 150 milliamps, for example, even if you set it only to 30 volts. Same with a total of 100 watts, even if you set it at 50 volts. It is limited to these specifications. It's a rather nice power supply with a dual line LCD display. It's completely microprocessor controlled. It has a foil keyboard and a lot of security features. Let's have a look how it looks on the back. Like that. It's not very spectacular. You have the fan. You hear the fan. IC socket and the switch, that's all. The interesting feature on this power supply is that you have these plugs that can be removed, and then you can use special high voltage plugs, or by using these ones you can use normal banana plugs like that. Okay, this is how it looks inside. It's a quite straightforward design. Let's start from a right lower corner. That's a digital part, the microprocessor or microcontroller. Here's the EEPROM under that strip line. You cannot see it. Here you see it a little bit. Foil keyboard connection. Then we have the complete analog section for the control, an auxiliary power supply, switch mode power supply for the analog section and the microcontroller section here. We have the input, the mains input with filtering. We have the high voltage rectification with two large capacitors in series. In series because you can use it for 110, then they are configured as a doubler, or 220 volts, then they are in series. Then we have the switching MOSFET. It's a larger one with it in a 20247 package. I think it's an RFPG40. Nothing really special. The special device is here. That's a big transformer. It's completely potted. That's the primary of the transformer. These two wires here. This transformer has a lot of windings. The whole output section is divided in a positive section and a negative section. You can imagine this imaginary division line. On the left side you have the positive section that goes up to 1000 plus 1500 volts, and on the right side you have the negative section that goes up to minus 1500 volts. These go then to the outputs here, the minus and the plus. The other interesting design is that they use they use four windings for the positive side and four windings for the negative side. Each winding with rectification, with a rectification module. For me, this is a module comprised from two two high voltage diodes in series in the snubber network. You see here we have the same circuitry 4 times on all sides, on both sides. The old design idea for this power supply is to not overstress the output components, the high voltage components. So this is why they are using not one high voltage, and for redundancy, not only one high voltage diode, but 2. First of all, to not stress it, and secondly, if one fails, still the other can continue working if it shorts, and it will not blow everything. The output design is a stacked design. And this design looks like that. You have more than one output windings on top of each other in series. So you have 375 volts here, 375 volts here, same here, and you had another one here, a fourth one, that gives you 1500 volts. This guarantees you that it will not overstress these components here, because they have to deal only with up to 375 volts. But in total, you have 1500 volts here. Here is a part of a partial redesign, or not redesign, reverse engineered output of an EPS 600. It's another version of this power supply for 600 volt only. And here you see how they do it. Here they have 3 in series. In our power supply there are 2 in series. Then the snubber and then the filtering. And here you have it both positive and negative. This is how it looks, more or less. And now let's have a look how it works. Self-test, a very annoying beep, and that's it. For example, I've set the output to 225 volts, 150 milliamps, and 59 watts. If I press the run button, it says that it starts without the load check. That means that all these power supplies have a security feature that will not output high voltage if they not see a minimum amount of load. Here it is disabled from the software. It is possible with a combination in the main menu to disable this. In many others you cannot disable it at all. And in some others you can disable it by making a hack from the hardware side. Let's do it again. Stop. It goes to more or less 0. Now we don't have anything on the output, and the capacitors are charged. This is why we see still 225 volts. Let's see how it works. I just connected a load fixture. It's a very interesting device that's in sections. Each section has one socket base, one lamp socket base. Here, for example, you have a E14, and here you have a G9. And in the G9 I have a 60 watt halogen lamp. I connected it to the output, as you can see here. And I set 225 volts, 150 milliamps. Normally we should see the voltage ramping up from 0 to 225 volts. Current check. And slowly goes up. The problem is that it's limited to 150 milliamps. So we already reached the 150 milliamps with the 60 watts. That means we have to take another lamp that draws less current. So I changed the incandescent bulb, the halogen lamp, to a 40 watt one that will not go over the 150 milliampere borders. So let's see how it's now. It slowly starts up to ramp. Till we reach the 225. So that's a 27 watt. In reality, because it is a special lamp that is 28 watt but gives light for a 40 watt lamp, and we already reached the 118 milliamps. At the moment I don't have any others, any bigger ones. Normally I had 40 watt here too, but I don't have. So this is how it ramps up, and with stop it goes down immediately. And you see the set voltage and the last current we used. As I said, it's a very nice power supply. Can be used with 3500 volts. Yeah, it can be used for many experiments. And now we'll see the maximum voltage that this thing can deliver. And now we will check how it works with 3500 volts. For that, I'm using a high voltage probe, a divider 1000 to 1. That means 3500 volts will be shown as 3.500 something volts. Here I already set it to 3500. And let's run it. Startup check. It ramps. It's very difficult. Oh, now here you can see it. We are already at 2900, 3000. We reached it already. It says 3500 and the multimeter says 3462. Well, to be honest, I don't know if the outputted voltage is 50 volts less, almost, or it's a divider issue. But you can see how fast it goes down. I can set another profile, 1500 volts, and let's see how it ramps up. The multimeter should show 1.5 something, or 1.48, same as before. And stop. And let's use another profile. Come on, 35 volts, so this is very low. Yeah, this will be shown the multimeter, yeah, the last two digits. Interesting. Okay, the reason why I had the beeping is because I had the load check enabled before. Let's see how we turn it off. Set. Current check, I already set it to no. Yes, no, and enter. And exit. And now we do the same again. We were started, 35 volts. And it's already on 0.034. That's 34 volts, 34 something, because we have the 1000 to 1 probe in use. And stop. Yeah, it doesn't go really down because we have the capacitors have some load still, and that's it. So this is for today. If you like my videos, if you like what you see, I would appreciate if you leave a comment or a thumbs up, or even better, subscribe. This would help me a lot. This would help the channel grow, so I can show much more things similar like that and much more designs. Thank you. Cheers. Here we can see some specifications. This is what I meant. 3500 volts DC maximum, 150 milliamps max, and 100 watt max. Programming ranges. The most interesting thing is here, or not most interesting thing here, it is, where is it here? The ripple. Less than 1% at the full output voltage of 3500 volts. 1% is a lot. So that's for today, guys. If you like what you see, if it was interesting for you, give me a thumbs up, please. Drop me a message. And please subscribe to my channel if possible. This will help the channel to grow, and so I will be able to show you more interesting things in the future. Cheers. Bye.